These are some practice problems to help you assess your understanding of what we've covered in the course so far. I'm going to read each question and then I'll put up the little pause icon so you can stop the video and answer the question on your own and then continue on at your own pace. Epidemiology is the study of the detection, structure, classification, immunogenicity, and evolution of viruses, the composition of human populations, including gender and age composition, births, deaths, and migration, how and why populations change in size and structure over time, or the distribution of disease in populations and the factors that determine that distribution. Epidemiology is the study of the distribution of disease in populations and the factors that determine that distribution. Answer A is virology, answer B is demography, and answer C is population dynamics. The other three answer choices are closely related disciplines that are used within the field of epidemiology. Florence Nightingale used incidence rates and incidence proportions to advocate for improved environmental cleanliness and decreased overcrowding, which she used statistical methods to demonstrate were contributing to excess mortality among soldiers during the Crimean War. Fill in the numerator and denominator for Nightingale's incidence rate in this example. Imagine dragging and dropping the lettered answer choices into the question mark blanks. An incidence rate is the number of new cases of a disease divided by the people at risk for that disease with an element of time in the denominator. In this example, the best answer choices are new cases of illness among soldiers attributable to poor sanitation divided by the population of British soldiers during the Crimean War in June. Because it's new cases specifically when we're talking about incidence, and the population in the denominator has to be people at risk of the condition of interest. Nightingale was specifically working on improving the health of soldiers during the Crimean War who were living in overcrowded and unsanitary barracks. The total British population was included as a trick answer there because British people who were not soldiers wouldn't be at risk of becoming ill due to unsanitary, overcrowded barracks. You have to be at risk of the condition in order to be included in the denominator. Which of the following explains the trends in disease X in the United States population? More cases of disease X are being diagnosed, but are being caught at an early stage when a curative treatment is effective, so new cases aren't developing into chronic disease. There's an increase in the number of cases with the increase in diagnosis, but the duration of disease is short because those new cases are getting cured. This would explain the incidence of a disease increasing without a corresponding increase in the prevalence within the population. You're reading an epidemiology paper that presents data on the deaths from a particular disease out of the people who contracted that disease. Which measure is this? Mortality rate, case fatality rate, incidence proportion, or standardized mortality ratio? Case fatality rate, which is the number of people who died during a specified time period following diagnosis, divided by the number of people with that disease. You read that African American men have a higher overall risk of death compared to the general population. The researchers divided the number of African American men who died that year by the population of African American men at mid-year. Which measure is this? Mortality rate, which is usually expressed as the rate per 100,000 population, but is sometimes per 1,000 population or a different number, but it always should be specified. Mortality rates can be calculated for all causes, for specific causes, such as cancer or homicide, for the total population or for population subgroups, or for exposure subgroups, such as in occupational health where people are exposed to certain chemicals that they work with. And it's important to note how mortality rate differs from case fatality rate in the previous question. For case fatality rate, we were dividing the people with a certain disease who died during a specified time period following diagnosis by all the people with that disease. In contrast to mortality rate, where we're dividing the deaths that occurred that year by the population at mid-year, not just the people with a certain disease. Mortality rate sometimes approximates the incidence rate if case fatality rate is high and survival duration is short. One other thing to note about mortality rate is that it's implied that the mid-year population is the same as following all the individuals in the population for one person year. That's what makes it a rate. But that isn't always perfect because births and immigration add people to the population, and deaths and people moving elsewhere subtract people from the population. But the mid-year population is often a good estimate for the purpose of calculating a mortality rate. What is the incidence rate of diabetes per 10,000 person years among people with pre-diabetes over the duration of this study? 2,500 per 10,000 person years. Remember that incidence rate is the new cases during the specified time interval divided by person time, and we're multiplying by 10,000 in this case because it asks for the answer per 10,000 person years. 2 people developed diabetes during the study, and to find the total person years contributed by the study participants, we add 1 plus 1 plus 3 plus 2 plus 1 to get 8 person years. So we divide 2 new cases by 8 person years, which gives us 0.25. Then we multiply by 10,000 to get 2,500 per 10,000 person years. A cohort study of gold miners was conducted to assess the health effects of exposure to arsenic, cadmium, mercury, and lead during gold mining. In 2024, 5 of 12,500 gold miners died from cancer. The cancer mortality rate in the general population in 2024 was 10 per 100,000. What was the cancer mortality rate among gold miners in 2024 per 100,000? For a cause-specific mortality rate, we divide the number of deaths from that cause by the estimated mid-year population and multiply by 100,000. 5 gold miners died of cancer during 2024, and there were 12,500 miners, which gives us a cancer mortality rate among the gold miners of 40 per 100,000. You volunteer to provide public health assistance in the Federal District of Brazil, which is in the midst of an unprecedented dengue outbreak with a prevalence of 14%. When you arrive in Brazil, the team lead explains the magnitude of the dengue outbreak to you by providing the number of new cases of dengue that occurred in the past month divided by the local population at risk. This measure is an example of cumulative incidence, which is a proportion. It's the number of new cases in a population during a specified time period divided by the number of people at risk for that disease during that time period. Remember that incidence rate has person time, usually person years in the denominator, and prevalence is the number of cases present in the population at a specified time divided by the number of people in the population at that time. Prevalence looks at existing cases, not specifically new cases. What was the all-cause mortality rate for females aged 20 to 34 per 100,000? Mortality rate is the deaths in a year divided by the mid-year population multiplied by 100,000. So we divide the 125 females who died from any cause, aged 20 to 34, by the mid-year population, then multiply by 100,000 to get 73 per 100,000. What was the proportionate mortality of COVID-19 for females aged 35 to 54? Proportionate mortality is the deaths due to the specified cause divided by deaths from all causes that year multiplied by 100. We divide the 70 people who died from COVID-19 in the specified age group by the 236 total deaths from all causes and multiply by 100 to get 29.7%. That's it for this set of practice problems.